Hello, I'm Sean Casinger, and for my senior project, I decided to build a laser engraver. So I figured I'd start by telling you a little about what exactly a laser cutter is and what it does, as well as why I decided to build one for my final project. Laser cutter is a machine that uses automated processes to engrave or cut designs into materials such as wood or paper. Of course, this process is automated, meaning that once you input a design into your cutter, it will produce the final product without any intervention. So you don't have to control the movement on your own. It will take care of that on its own. This type of control is called CNC, or computer numeric control, meaning that you give it a design and it will produce the product on its own. And these are some examples of things made using laser cutters. The first one, it is a enclosure for a radio. It's a little more for amateur electrical hobbyists. If you make a circuit project, it's a little more impressive to show this to your friends than a messy circuit board that's just a bunch of wires and ugly components. So that's more decorative. It can also be used for functional, as in this case, where they use laser cut pieces to make the frame of a 3D printer, which I found particularly entertaining because someone used a laser cutter to make the pieces for a 3D printer, and I in return used a 3D printer to make the pieces for my laser cutter. So you got the chicken and the egg. How it works. In order to engrave or cut designs in a material, I needed a way to move a laser over a flat material such as paper so I could cut my design into it. In order to do this, you need to control the movement of a laser in 2 dimensions. So in order to help me explain this, I've employed the trusty Etch-a-Sketch. So as you all know, you only have 2 directions in which you can move the pointer. You can move it straight side to side, you can move it straight up and down. If you want to build something like this, which doesn't have any lines that are straight up and down or side to side, you would need to use a combination of both the side to side movement and the up and down movement at the same time. A human isn't very good at this, but if you are precise enough, you can use the dials in the right order to produce the shape you want. So how I use this concept to produce my laser cutter is I needed motors that were capable of moving in precise increments. If you tell your laser to move 1 inch, you want it to move 1 inch exactly. And if you tell it to move another inch, you want it to end up 2 inches from where you started. The problem with conventional DC motors is that you tell them to spin, and they just start spinning, and there's no knowing where they'll end up. So to solve this problem, I used stepper motors. Stepper motors are capable of rotating in fixed, precise increments, which you can use to produce linear movement. This is my design that I used. You can see in the red are the stepper motors, which so this one is paired to the bed, which causes the bed to move in this direction. And this stepper motor is paired to a head that is not in this drawing, but moves in the side-to-side direction. So comparing this to the Etch-a-Sketch, it's the same functionality, it's just different for the sake of simplicity. Because I could have had the laser move side to side and back and forth, but it's complicated to have one thing move in 2 directions. It's easier to have 2 things that slide, because these are both on rails, so they just move in 1 direction each, and that just simplifies the process. The design. So to make this, I use 3D modeling software to design the frame, and I used 3D printers to print out the frame. And this is where I encountered one of my problems, which was that I used threaded rods to hold this thing together. You can see some here. the diameter of the threaded rods was half an inch. So in my design, I made the holes half an inch, but they're exactly the same size. So when you try to put the threaded rods through the holes, it wouldn't fit. I solved this just by redesigning the pieces with proper tolerances and drilling some holes that I couldn't redesign. The hardware. So to get from a digital design to a physical object, there's a series of hardware that needs to communicate with each other. So first you need to start out with the design, which you typically have in your computer. You can design this or you can find them online, but you need to start with the design. And then you upload this design into software. I use this one called Universal G-Code Sender, which communicates with my microcontroller. It sends instructions from the computer to the Arduino, which I use to control my laser cutter. The microcontroller receives instructions from the PC and tells the motors how they should move. And then the stepper motors, they receive these signals and create linear motion, which produces the image. The results. In the end, I was able to get the computer numeric control portion of this project working. I was able to upload designs and control the motion of the machine. I did unfortunately have an issue with the one piece that is in the name of the project, which is the laser. In order to burn an image onto the material, I needed a lens to focus the laser onto a fixed point so that it would cause burning on the material and create an image. The laser case I acquired was not able to focus the laser in short enough of a distance to cause significant heat buildup and burn an image into my paper. As a temporary workaround, I attached a pen to the machine in place of the laser, just to prove that I could produce images. So despite that one small hiccup, I do consider this project to be a success, and I was able to draw that with my machine. Are there any questions?
Does the laser move or does the platform move around?
Both. So the laser moves side to side, and the platform moves back and forth, basically. So each moves in one direction, so that, yeah, it's similar that way. Okay, well, thank you.